Hello everyone, I am Janet Madanayak from Intake 34 and this is regarding my final year research project which is the prediction of bond strength reduction at steel concrete interface due to corrosion. Introduction. The service life of structures deteriorates corrosion. The bond between steel and concrete is the key feature that decides the use of concrete as a construction material. Basically, the effect of corrosion is on the surface properties of the steel, which will exert tensile properties on concrete while making new compounds, which will result in formation of cracks. Research need. The research is significant since the effect of corrosion on reinforced concrete structures is a major burden to the lives of people. This can directly affect the economy of a country with the cost needed to repair them. Further, by knowing the amount of strength reduction, necessary retrofitting methods could be applied for the structures. Objectives. The main objectives of the research are to investigate the effect of corrosion on the bond strength between rebar and concrete and to develop a model for calculation of bond strength reduction due to corrosion. Methodology. This research mainly consists of 5 tests. They are accelerated corrosion test method, pull-out test, deflection and bending test, chloride ion concentration test, and corrosion percentage test. Test specimens and data. Concrete beams and cylinders were made with different concrete grades, rebar diameters, and corrosion levels. Numerical analysis. Numerical analysis was done by abacus, and you can see the stress distribution with the displacement simulated from abacus. Let us move on to the results and discussion part. Results and discussion. Starting with the experimental values of pull-out test, it can be seen from the graph that the bond stress relevant to the moderate corrosion levels are reduced to about 55% and severe corrosion levels are reduced to about 70% when compared to the no corrosion stage. But the reduction of bond strength is less for the specimens with grade 25 concrete compared to grade 20 concrete. The results obtained relevant to different specimens from the finite element analysis are shown in the given table. When comparing the variations of the experimental and numerical values, they show likely the same trend of variation except the values relevant to the control samples. Numerical values of bond strength, moderate and severe corrosion levels are higher than the experimental values. Free and total chloride ion concentration test results. It can be seen that the acid-soluble chloride ion concentrations are higher than that of water-soluble chloride ion concentrations throughout all depth levels. Analysis of formation of rust and reduction of rebar diameter. It can be seen for both grades that the corrosion percentage has increased and it has decreased with the increase of rebar diameter as well. Let us move on to the conclusion. Conclusion. The bond strength decreases with the increase of corrosion level. Also, the bond strength is directly proportional to the concrete grade, whereas the bond strength is increasing with the increase of concrete grade. Furthermore, the effect of rebar diameter on the bond strength reduction can be seen in all corrosion levels, and there is a significant reduction of bond strength with the increase of rebar diameter. The chloride ion concentrations are increasing in depths from rebar towards the outer surface, and hence the transportation of chloride ions is through the cracks rather than by diffusion. And with that, I wind up my presentation. Thank you for the attention.